So far, we've seen Chris install and configure a Novell LAN. Now we're ready to begin performing the day-to-day management tasks. In this module, Susan will show us some of the many tasks which are part of an effective management program. These include maintaining the LAN, securing the LAN, and finally, adding new applications to the LAN. Let's begin with maintaining the LAN.
Maintaining your LAN involves periodically checking elements of your network that impact performance. These include the connections, packet traffic, the server's memory and hard disk, as well as the bindery and the volume. One of the most useful management tools I use is a maintenance schedule. I keep it to make sure that nothing is overlooked. Another useful management tool is RConsole. RConsole is used to make any workstation look just like the file server's console. This is really useful to a LAN administrator because you can do many of the maintenance tasks from your own workstation. As you saw earlier, the control and escape keys are used to move between screens at the file server console. However, there is a slight difference when using RConsole at a workstation. To move between screens, you use the plus and minus keys. In addition, the shift key, in combination with the escape key, is used to exit RConsole. To get a better idea, let's run RConsole by typing RConsole at the command prompt. Then you'll be shown an available servers window. Here we'll select the server we want to view by pressing Enter. RConsole requires a password before we can access the file server. The password we type in won't be shown on the screen for security reasons, and you can add an additional measure of security by using a different password for each server that you access. Now that we've entered the password, we have control of this server's screen and keyboard. This means that we can access the command prompt and utilities that normally can only be accessed on the server's console. These include the console command prompt, the print server, and the monitor utility. We will be using monitor to do many of our maintenance tasks. Let's talk about how it works. As you may recall, monitor is an NLM that gathers information from various sources on the file server and displays this information on the file server screen. Of course, since we're using RConsole, this information is being displayed on our screen. Let's see how Monitor will help us check the LAN connections. At Monitor's main screen, we can see how many users are currently logged in or connected to the network. This number is important because, as you know, every LAN is licensed for a certain number of users. If the number of users logged on reaches the maximum, additional users will be unable to log on until someone else logs off. It's important that you keep track of the number of users you have so you can plan to upgrade your license for more users before you reach the limit. We can also use Monitor to ensure that packet traffic on the LAN is functioning normally. To do this, let's choose LAN information from the Available Options window. This will display a window listing the NIC drivers installed on the file server. Select the driver that you want and push Enter to view that driver's statistics. The statistic that you need to check is the number of packet collisions. Collisions happen normally on an Ethernet LAN and will be recorded in the NIC statistics. In the LAN driver statistics window, look under your custom statistics for the collision counter. The counter will be called by a different name depending on the type of NIC you have. In this example, it's called the excessive collisions count. If the collisions count is rising rapidly, it may be caused by heavy traffic or a hardware problem. We'll go into more detail about the possible causes of excess collisions in a later module. To get specific information about the collision counters for your NIC, you should refer to the appendix of Novell's System Administration Manual. Now, let's check the server's memory. This is done by checking the cache buffers in the file server. Cache buffers are a pool of memory in the file server's RAM used to store frequently used data and applications. This allows faster access time because the workstation can request information already in the cache instead of having to read it from the hard disk. During network configuration, a portion of the server's memory is allocated for the network operating system, which may include NLMs, the print server, file allocation tables, and drive mappings. The cache buffers that are left are used for such things as applications and files. As users access more files and applications, more cache buffers are used. In addition, NetWare will take up more of the cache as the LAN grows and new users and NLMs are added. This will leave less cache buffers available for data. We can see this percentage of available cache buffers by selecting Resource Utilization from the Available Options menu. Resource utilization will take you to the Server Memory Status window. If this percentage falls below 50, the performance of the server will start to deteriorate, and you'll need to start thinking about increasing your server's memory. In general, the lower the percentage gets, the more problems your server will have.
Let's quickly review what we've learned. Susan has shown us how to use the monitor utility to check logical connections, packet traffic, and cache memory of the file server. Monitoring such things as LAN traffic and server memory will help us detect potential problems and anticipate future needs. In the next section, we'll be taking a look at checking the hard disk on the file server. In the last section, you saw how to monitor both network traffic and memory usage. In this section, we'll be taking a look at checking the hot fix area on the hard disk. Then we'll talk about backup systems, which include the tape backup and the uninterruptible power supply, or UPS. Next, we'll look at the bind fix utility and the TTS error log. Finally, we'll see how the purge utility is used to delete files from the hard disk. Let's listen to Susan as she talks about monitoring the hot fix area.
Now that we've checked the cache memory of the file server, we need to check the hard disk for any signs of degeneration. To do this, we'll look at disk information under Monitor's Available Options menu. If there is more than one disk drive installed on the server, you will need to choose which disk to look at. In this case, we only have one, so we'll press Enter. Here, it's important to pay attention to the hotfix status. When you look at the hotfix status, it should say Normal. If it says that the disk is not hotfixed, then the hotfix function has failed, and you should consider replacing the hard disk. Hotfix is a NetWare function that protects data on the hard disk. If a block of data is being written to a bad area on the disk, it's moved to the hotfix redirection area. This area is automatically reserved when the system is configured. The bad block is then marked and is not used again. To see if blocks of data have been redirected to the hotfix area, look at the redirected blocks count on the disk information screen. If the number starts to rise, this means that more and more bad blocks are being found. This is an indication that your disk is failing. Since all hard disks will eventually fail, it's important to have a backup system. One of the most common types is a tape backup system. Some systems are internal and others are external. Let's take a quick look at how tape backup works. Most often, the backup system is connected to the LAN administrator's workstation. At night, after everyone has left for the day, the system automatically logs on to the file server. Unattended, the backup system copies the data from the server's hard drives to a tape. In order for the tape system to be able to log in, you need to assign it a user account. You can create a user solely for the purpose of tape backup, but most often it's easiest to use your own user account. In my case, the backup is assigned to Susan. The user account that the backup system uses has to have supervisor rights so that the system can access all of the directories and files it needs to back up. If you do create a separate user, you have to assign it supervisor rights. You can set the backup system to back up all of the files, which is a full backup, or only the ones that have been changed since the last backup, which is an incremental backup. In addition, you can back up specific files that you've chosen, which is a selected backup. It's the usual practice to do an incremental backup on a daily basis and a full backup weekly or monthly. In addition, tape systems can be configured to back up specific things like the bindery, hidden files, and subdirectories. Many backup systems generate a log after each backup. You may find some error messages, such as a file that cannot be copied. In many cases, this is normal. If you're unsure, check past error logs to see if the message occurs consistently. You can do tape backups any time of the day, but it's best to do it when the server isn't busy. You can also keep data safe from disasters like fire by keeping a copy of the tapes at another location. NetWare has a utility for backup called NBackup that can be used in place of third-party software, but I've chosen to use a third-party tape system for this network. Another type of backup that's really important is an uninterruptible power supply, or UPS. There are two basic types of UPSs, a dumb UPS and a smart UPS. A dumb UPS is no more than a battery that keeps the server going in the event of a power fluctuation or outage. The battery will power the server for about 3 to 10 minutes, which gives you a chance to get the users logged off and down the server. However, if the battery is left to support the server for a period of time, the battery will become low on power. When that happens, the server will simply crash. A smart UPS is different. If you buy a smart UPS, you will need to install the UPS NLM that comes with NetWare. Also, a smart UPS has a second cable that is connected to the server. This cable communicates with the UPS NLM and notifies the server if the power is discontinued. If the power is discontinued, the UPS will alert you by sending a message that the UPS is supporting the server and may ask all of the users to log out. When the battery in a smart UPS falls below a specified power level, the UPS will automatically close any open files and safely down the server. Now that we've covered the issue of backup, let's return to our maintenance schedule. Another task done on a regular basis is cleaning up the bindery. As you know, the bindery holds information on objects such as users. But when a user is deleted, their information stays in the bindery. A utility called bindfix will let you delete this old information. For instance, Jim Mullen was recently deleted from the network. When we run bindfix, it will clear the bindery of the objects, properties, and values associated with him. When bindfix is executed, it indicates which area it's currently checking and then prompts you to delete old information. When it's finished, bindfix will tell you that the check was successful and will save a copy of the original bindery files using the extension .old. You can delete these files at a later date if there are no problems on the network. If there are problems, you can restore these old files by using the bindrest utility. Next, we need to check the Transactional Tracking System, or TTS, error log to see if any errors that could affect the bindery have occurred. Let's look at what TTS is. TTS is an integral part of NetWare 3.1.1. It protects the NetWare bindery and other database files that are flagged as transactional. As you may know, information in a database file is organized into records. When a record is accessed, it's automatically locked so that no other user or applications can make changes to it. In addition, TTS will make a copy of the original record. If a network component fails while the update is occurring, because of a problem such as a power outage, the record may be corrupted by being incomplete or scrambled. Once the power is restored, TTS will then back out of the transaction by replacing the corrupted record with a copy of the original record. These occurrences and other errors are recorded in the TTS error log file. It's important to check this log frequently. This can be done with any text editor. The file you want to look at is called TTS$log.err. From a text editor, you can view this file. I typically get a printout as well. If a database application won't automatically work with TTS, you can flag it as transactional and it should work. We'll talk about flagging files later in the module. Another error log that you need to check keeps track of volume errors. The file you need to check is called vol$log.err, and you can use a text editor to see any errors that might be listed in this log too. It's also a good idea to print it out as well. When you're checking the volume, you also want to see how much space is left and how much space is being taken up by deleted files. To see this information, use the checkvol utility. Type checkvol at the command line, and you'll see the volume information displayed on the screen. As you can see, here is the total space in the volume, which is taken up by active files and deleted files. Here you can see the total space available to you, but the available space includes that of deleted files. So you need to make note of how much space is being used by these deleted files compared to the space that's remaining. The difference between these two figures represents the space on your volume that will be used before NetWare will begin purging deleted files. Let's talk briefly about the difference between deleted and purged files. When a file is deleted, it becomes invisible to the user, but is still taking up space on the hard disk and can't be written over. But once it is purged, the file can be written over and replaced by new data. As I mentioned before, NetWare will automatically purge files once free space runs out. We can avoid the uncontrolled purging by purging files ourselves. Now let's talk about how to purge deleted files. Go to the command line and type purge. Here you have several options. For example, you can remove an individual file by typing in the file name, a category of files, or all the files in the directory and its subdirectories.
In this section, Susan showed us how to check a hard disk's integrity by looking at the hotfix status. She also talked about backup systems for the file server. We then saw how to run bindfix to delete excess information from the bindery. We also looked at the TTS error log. Susan then explained how to use checkvol to keep track of volume space. And finally, we saw the difference between a deleted file and a purged file. In the next section, we'll look at security and the types of tasks you need to do to ensure that your LAN is secure. So far, we've seen the various tasks involved in maintaining the LAN. In this section, Susan will talk about how to implement network security. This will include running a virus protection program and using Monitor to lock the file server console. We'll also look at the user list command, which keeps track of who's logged into the network. Finally, we'll see how to set station, account, and time restrictions for users on the network. Let's listen to Susan as she talks about virus protection.
As a LAN administrator, it's your job to make sure that the network is safe from tampering. An important part of making your LAN safe includes installing a virus detection program. A virus is a program designed to impair or destroy data. Most often, a virus will start from a workstation that has used an infected floppy disk. When that workstation writes to the file server's hard disk, the virus spreads to the server. This is where the real damage can start. It may even bring down the network. This can be avoided by using a virus detection program. A typical virus program will scan three things: the hard disk, the memory cache, and floppy disks. In addition, most programs will get rid of any detected virus and may prevent reinfection. You need to protect the server from external tampering as well as internal tampering. One way to do this is to keep the file server in a secure place, but you can also lock the file server console itself. This prevents anyone from tampering with the console and damaging the network. To lock the console, go into Monitor and select the Lock Keyboard option. A box will come up prompting you for a password. You will need to enter that password the next time you want to unlock the keyboard, so make sure it's a password you'll remember. In addition to making sure the file server's console is secure, you need to make sure that users aren't leaving their workstations logged in and unattended when they leave for lunch and at the end of the day. To do this, type in user list at the command prompt. You'll be shown a list of the users that are logged into the server and what time they logged in. For instance, Jim last logged in at 8:10 a.m. If the time is currently 2 p.m., we could conclude that this person didn't log off at lunchtime and may have left the workstation unattended. If you do find a user logged on, it's possible to see what files they have open, and if it seems necessary, you can remotely log them out. This is done through the Monitor utility. In Monitor's main screen, select Connection Information, which is the first choice in the Available Options window. This will show you the open connections that will correspond to those you saw with the user list command. Remember that Jim has been logged in since this morning, so let's see what files he has open. Just highlight Jim and press Enter. You can see the files Jim currently has open, and it looks like one of these is pretty sensitive in nature. If there is a file that really needs to be closed before Jim gets back, I can just walk over to his workstation and log him out myself. But if I can't get away, or if he's in another building, there is another option. I could clear his connection remotely. I'll show you how it's done. Back out of the Open Files window to the list of open connections. Press Delete, and we're asked if we want to clear the connection. Yes is already highlighted, so we'll press Enter. Now, Jim isn't on the connections list, which means he has been disconnected. Remember that clearing the connection should only be done as a last resort because files that aren't saved may be lost. There may be times when you need to restrict a user's access to the network. There are three types of restrictions that you can use. They are account, station, and time restrictions. To restrict a user, we'll use syscon. Select user information from the main screen, and then choose the user you want from the list. We'll select account restrictions from the user information window. From this window, you can control things such as password usage or the number of stations a user can log into at one time. This is useful if you have a person who roams around from workstation to workstation without ever logging out. You can also give the account an expiration date. This is good for temporary employees or someone who is leaving the company at a certain date. You also have the option of disabling an account immediately. Let's escape back to the user information screen and select Station Restrictions. Station restrictions will allow you to determine which workstations a user can log on to. This is done by typing in the node addresses of the workstations you'll allow the user to access. Lastly, you can restrict the time that this person can log on to the network by choosing Time Restrictions. This will show you a calendar which will allow you to restrict the user by deleting time in hours or days. Using syscon to implement these restrictions can help you to control your LAN.
Now let's do a quick review of this section. We talked about the importance of virus protection. We also saw how to lock the file server console. Then we saw how to run user list to make sure workstations are not left unattended. We also talked about how to restrict accounts, as well as restricting the stations and times that users can access the network. In this next section, Susan will explain other types of security, which will include detecting security violations and file security. In the last section, we talked about establishing a secure network. In this section, Susan will continue discussing the issues of security. We'll begin with the security utility, which is used to check certain network security violations. Then, we'll talk about login security. Next, we'll discuss rights, which will include trustee assignments, IRMs, and effective rights. And finally, we'll take a look at attributes. Now, let's listen to Susan as she discusses the security utility.
We've looked at preventing security gaps, which is the first step. The next step is to search for security gaps that may already exist. You can do this by using the security utility. By typing security at the command line, the utility will check all objects, mainly users, for possible security violations. For example, it will list who has supervisor rights. More than 2 supervisor equivalents is considered a violation. Security also checks to see if everyone has a full name listed, since some first names may be common. Another violation is a missing user login script. This isn't really a cause for concern because, as you know from configuring the system in an earlier module, giving each user an individual login script may be unnecessary. Security also checks user accounts. If a user hasn't logged on for over 3 weeks, it'll be listed. Security will also tell you if an account has expired or has been disabled. Security also checks passwords and makes note if there is no password or if a password is insecure, which could mean it is too short or easy to guess. It will also indicate if a user is not required to have a password, change their password periodically, or is allowed to have a password that is too short. You may want to redirect the security program's output to a file or redirect it to the printer. This can be done using DOS redirectors. A major part of security involves regulating who can get on the network, what data can be accessed, and what can be done with the data. Let's talk about the 3 levels of security: login, rights, and attribute security. Login security regulates who can get on the network by requiring the user to have an assigned name and a password. The user must first enter a login name, then enter a password that is screened by the file server. If it's an approved password, the user is given access to the network. Once a user is on the network, they come to the next level of security, which is rights. As you may remember from installing and configuring the network, users and groups are given rights to access certain directories and files. These rights are called trustee rights simply because a user becomes a trustee of a file or directory if they have rights to it. Let's look at an example of how user rights work. One of the directories on our server is the accounting directory. This directory is at the highest level and is called the parent directory. The parent directory may have 1 or more subdirectories underneath it. In this case, payroll is a subdirectory of accounting. Greg, a new user, hasn't been given a trustee assignment to the accounting directory. Therefore, he has no rights to it, or the subdirectories below it. However, the accounting group does have a trustee assignment for the accounting directory. As you can see, they have read, write, erase, and file scan rights. The subdirectories and files below this trustee assignment inherit these rights. If we add Greg to the accounting group, the group's rights become his rights too. The group's rights plus any rights Greg may have had make up his combined rights. Let's see how additional security can be added by using the Inherited Rights Mask, or IRM. The IRM acts as a filter which masks out selected rights that subdirectories and files inherit from the trustee assignment. In this case, the IRM has been set to mask out the erase right in the payroll subdirectory. Therefore, the erase right is no longer effective in the subdirectory or any subdirectories or files beneath it. The rights that are left are called the effective rights, which are the rights that can actually be used. This is an involved concept, so let's go through it again. Greg starts out with no trustee assignment in the accounting directory. The accounting group has read, write, erase, and file scan rights. When Greg is added to the accounting group, he gains their rights. These are Greg's combined rights for the accounting directory. The IRM is assigned to the subdirectory called payroll and is used to mask the rights in it and the subdirectories and files beneath it. In this case, the IRM has been set to block the erase right. This means that the effective rights, or the rights that can actually be used, are read, write, and file scan. To set a user's rights, use syscon. Under User Information, choose the user you want to work with. Let's pick on Greg again. Select him and the User Information Options window comes up. Then we'll choose Trustee Directory Assignments. This window would show the directories that Greg has rights to, but as you can see, he only has rights to his mail and home directories. We could give him other directory rights here, but let's do it by adding him to a group that has the rights he needs. So let's go back to the main menu and select Group Information. Listed here are the groups on the network. Greg is in the accounting department, so we'll add him to the accounting group. But first, let's see what the group's trustee assignment is. To do this, press Enter to get to the group's information window. Then we'll choose Trustee Directory Information. As you can see, the group's trustee directory assignment is to the accounting directory. It looks satisfactory, so let's go ahead and add Greg to the group. First, we'll need to go back to the group information window and select Member List. This shows you the members that are currently in the accounting group. When you press Insert, you'll see the users who aren't in the group. Here's Greg. We'll highlight him and press Enter. And now he's a part of the accounting group. As a part of this group, Greg now has the same trustee assignment to the accounting directory that the group does. When I add users to the network, I don't bother assigning them individual rights. Once I've assigned them to the groups they belong to, the user receives the group's rights, which are all they usually need. This makes adding users faster and easier. Now, the accounting directory has a template called template.doc that they use for purchase orders, and it's important that this file isn't erased. The accounting group has the rights to erase any of the files in the accounting directory, but we can protect this file by setting the inherited rights mask. This is done through Filer. We're still in the accounting directory, so to get to the file, we need to choose Directory Contents. In this list, we need to find the template file. Here it is. By pressing Enter, we're shown some file options. We need to choose View Set File Information. Among the information we can see for this file is the inherited rights mask. As you can see, all of the rights are shown, which means that none have been masked. We'll mask the erase right, so let's press Enter and call up the IRM window. Select the erase right and press Delete. We're asked if we want to revoke this right. We do, so we'll press Enter and the erase right is gone. Now the accounting group won't be able to erase this file. As you have seen, the users have rights called trustee assignments that govern how they use files and directories. But what if you have a special directory that you want hidden, or you don't want a file copied? Although you can't protect these directories and files by assigning them rights, you can protect them by setting attributes. When an attribute is set on a directory or file, it is said to be flagged with that attribute. Let's take a quick look at a few of the many file attributes there are. The delete inhibit attribute prevents users from erasing files, and the hidden attribute will hide a file and prevent it from being deleted or copied. The read-only/read-write attribute is used extensively. Every file is flagged read-write unless you modify it to be read-only. And the shareable attribute allows more than one user to access a file at the same time. Directories also have attributes. One example is rename inhibit. Like the name implies, this attribute prevents users from renaming directories. Another example is hidden. Let's go through how to flag a directory with a hidden attribute. First, you need to go into the directory you want to flag, then run the filer utility. The main menu gives you a list of available topics to choose from. The one we want is current directory information. Since that is the first item on this list, just press Enter. Within this window, select Directory Attributes. This will show you the attributes the directory currently has. According to this, there aren't any attributes assigned yet. To add an attribute, press Insert. Here you can see a list of the available attributes. Choose the Hidden Directory attribute and hit Enter. Now, Hidden Directory is one of the current attributes. All other attributes can be assigned the same way. Now that we've flagged the directory, let's flag one of the files in it. The process is similar. From the available topics, choose Directory Contents to see a list of files. To get to the files, go past the subdirectories. Let's choose payroll.doc. Press Enter, and you will get a File Options window. We need to set file information, so we'll choose this option. The first line has the attributes set for this file. As you can see, it's already flagged read-only, archive needed, rename inhibit, and delete inhibit. Important files like this are often sensitive in nature, so let's flag this copy inhibit also. To do that, press Enter, and here you see the attributes on this file. Press Insert, and here are the attributes not yet assigned. Copy inhibit is the first one, so we'll just press Enter, and you can see that copy inhibit is now added to the list of currently used attributes. If you press Escape, you will see the addition of copy inhibit in the File Information window. Unlike trustee rights, attributes aren't inherited. So if you want to flag a file, you have to do it at the file level because directory level attributes won't be passed on.
Okay, let's take a minute to review what we learned in this section. We saw how the security command checks for possible security risks. We also saw that login security is made up of an assigned user name and password. Next, we learned that rights security is established through combined rights, the IRM, and effective rights, which provide directory and file security. You also learned about attributes, which provide additional security. In the next section, we'll be taking a look at adding new applications to the network. So far, we've taken a detailed look at day-to-day network maintenance and security. In this section, we'll talk about one last task, adding new applications to a LAN. Let's listen to Susan.
Something that every LAN administrator has to do sooner or later is to add a new application onto the LAN. It may be a graphics program, a database program, or maybe even Windows. But no matter what type of application it is, there are a series of steps you need to take to make the addition successfully. Let's go over a checklist of these steps. The first thing you need to do is take note of the size of the application. Then use check vol to check your disk space to make sure that it will accommodate the application. If not, you will need to free up some disk space or choose another application. Ideally, you should know how much disk space you have to work with before you go application shopping. When you've determined that your chosen application will fit, you need to create a directory for the application and assign a network drive to the directory. As you may recall, this is done by using a map command in the system login script. You may need to include the root parameter, since some applications may want to install from the root level. When that's done, install it onto the server's hard disk according to the instructions that come with the software. Every application is different, so be sure to read the instructions carefully. Once the application is installed, you may need to flag it read-only and shareable, unless indicated otherwise by the instructions. The read-only flag will keep users from editing an application that needs to stay intact, and the shareable flag lets more than one user access the application at one time, which is important for a network application. As you may recall, the filer utility allows you to set flags. At this point, the application has been placed on the hard disk and has been secured. But in order for the users to be able to use the application, we need to give them access to it. This is done by giving them trustee file rights through the syscon utility. And remember, if every user is a part of all the appropriate groups, you'll only need to work with group rights, not individual rights. The next step is to add the necessary mappings in the login scripts for everyone that will need access to the application. You should also test the mapping by using the test user account that was created earlier. By assigning the test user to the groups who have been given access to the application, you can confirm that the mappings are correct. Lastly, confirm that the correct users and groups have rights to the application subdirectory. This is done by using filer. At the command prompt, type filer. At the main menu, select Directory Contents. Then, select the application you installed from the Directory Contents window, and this will bring you to the Subdirectories Options window. Select Who Has Rights here, which will give you a list of all the users and groups who have rights to the application. As you can see, adding an application to the LAN is really easier than you might think. All you need to do is take your time and check your work. Let's do a quick review of the utilities we used in this module. Our console is used to access information that is normally displayed only on the file server's console. For example, to use the monitor utility from your own workstation, you would first run our console. Monitor is used to gather information about your network. We used it to check a number of things, such as the available cache buffers in RAM and the hotfix status. You can also use Monitor for a variety of other things, such as viewing a list of NLMs that are loaded on the server. Another utility that we used is filer. As the name implies, the filer utility is used to access information about files and directories. For example, we used filer to add attributes to the payroll file and to set the inherited rights mask on an accounting file. Filer can also be used to check volume information or to see who created a file and when it was created. The last utility we used was syscon. As you've seen throughout this course, the syscon utility is used to set up the overall system and the users and groups within the system. In this module, we use syscon to give the accounting group a trustee assignment for their directory. We also set time, station, and account restrictions. As you've seen in earlier modules, there's a lot you can do with syscon. I encourage you to explore the options in each utility that we use to manage the LAN and become familiar with what they can do for you.
Well, throughout this module, we've talked about network management. This includes day-to-day maintenance tasks and dealing with security. In the next module, we'll take this one step further. We'll look at troubleshooting some of the most common problems on the network.